This is an introduction to my theory of grand unified physics. What I want to go over here is some of the ways I came up with this theory, with some motivating factors, some of the things I look for in a grand unified theory, how to think about it, and it's not as technical as the other theories, the lectures that I've done, because there I kind of speed through a lot of things like the equations, Einstein field equations, the Klein-Gordon equation, Fourier series spectral resolution of elliptic partial differential equations, second order, stuff like that. So this is not nearly as technical. Let's proceed with what we want a unified field physics theory to be. You look at the universe, and I guess you'd have to make a little bit of an assumption before you really start to think about it. But you basically want to say stuff like, does it appear to make sense at first, or at least get some confidence that you're able to even perceive it correctly, or like philosophical questions, like what Kant says, what a priori reasoning and free will and stuff like that. Not to question your free will, but just to realize that you can make predictions about something if you have a way of approaching it. It's not really epistemology, or at least it's not very deep. Actually, it's a lot deeper than what Kant does, but this is not really about philosophy or advanced philosophy or epistemology and that sort of thing. It's more about having confidence in what you see is real, or at least perceivable, organized, or you can think about it or reason about it. And you should really believe in that before you begin this. But here we go. You see the universe as one whole, consistent thing. It's a little bit elaborate to speak of the universe as a whole. According to the Einstein field equations, it appears to go on forever. That's kind of a strange thing in itself, but I'm not saying the matter in it is infinite. I'm saying that the curvature of space never really falls off. Quantum mechanically, you might think it would diminish towards zero at some threshold of by quantum, it became so minimal that the quantum conjugate particle and antiparticles canceled out so that it formed essentially null particles. That might be the case. Let's just assume it's infinite. You say it's very large and one unified thing, and the same laws of physics hold everywhere. Now, it took physicists quite a while to realize that. A lot of people thought there were magic circles and magic realms and stuff, that like alternate universes, even one of the more grandiose things other physicists have thought of. The universe doesn't really work like that. It's a little bit like that, but it's not really. So let's just say it works the same way everywhere. That's really physics. I guess it's philosophical. It's mainly physics to realize that the universe is the same everywhere. So the universe is a three-body problem, even more complex. It's also not the same anywhere. There's no two places where the curvature due to the three forces, strong, electroweak, and magnetic, or strong, electroweak, and gravitational are ever the same. All three of them never correspond. Not that they cancel, but rather that it's never the same in any particular space. Each point of space is different. I began to realize the universe should be complete, whole, unified, consistent, non-contradictory, integrated. Non-constant is a bit complex, but let's just say non-constant. I began to think of it this way. I also looked at the equations for a very long time. Although electrostatics and gravity look very similar, a lot of the other forces don't. For instance, the symmetry of Maxwell is 4 or 5. Symmetry of Newton is 3 or 4. Even with vectors taking up 3 apiece, it's still a high count, and the two don't really seem to lead to much insight. And quantum mechanics has been reasoned out fairly well in quantum field theory. They view it as a vector space additional for defining path integral, null for closed curves, and they're based on the Heisenberg uncertainty principle. So that was cleaned up. It's pretty clean looking. Even something like Newtonian mechanics falls under vector analysis, the 8 laws of linear spaces. So that's fairly tight too. And you look at the different principles, superstrings, quantum field theory. There's really no way to unite those things. You really have to take a different approach. And my approach has been to consider it as a bunch of logical statements. I eventually arrived at the number 36, the number of statements. I was looking for I knew it had to be a fairly high count. And, the thing about it is that And 36 reduces to 2 times 2 times 3 times 3. If you think about it more elaborately, 1 times 1 times 2 times 2 times 3 times 3. You think about it more elaborately, it also reduces to 1 plus 2 plus 3 times 1 plus 2 times 3. Or 1 plus 2 plus 3 times 1 times 2 times 3. Or 1 times 2 times 3 times 1 plus 2 plus 3. Like back and forth, addition, multiplication, addition, like that. So you really think about it that way. I realized that 6 was a perfect number. It's the only number that's the sum and product of its factors. Or 1, 2, and 3. 1 times 2 times 3 is 6. 1 plus 2 plus 3 is 6. So a unique number. And when you think about that more and more, you think that it might be 6-dimensional. I believe the quantum chromoforce is 6-dimensional, 1 over r to the 6th. And although it falls off at large distances, not even that far, like 10 meters or something, that is indeed consistent with my theory. Like, you tend to think it might be changing the number 6. 6 is strong as a perfect number because there's 2 ways of expressing it. Essentially means it's quantum mechanical. If you view quantum mechanics as a statement that nothing is in the same place at 2 times, or nothing has locality in one place at one time, you can view it different ways. Nothing is in the same place at 2 times. Nothing is in the same way at 2 different times. Like 2 times, 1 space, 2 spaces, 1 time. Kind of like an oscillation between those 2 modes. Basically what I did is I just batched together all the common other ingenious things physicists have thought in the last 2 years, several years, 20 or 30 years, 50 years. Kind of grouped them together and kind of formed a integrated approach to it. The thing about it is that I read a lot of Gribben and Pede and stuff like that, and Bohm, and when I was younger. And the advantageous thing about that is it teaches you how to think about cosmology in a different way than just learning college physics from like Halliday Resnick. There's one, or Tipler. They're 2 of the better books, but Giancoli even. But you really can't learn much just trying to duke it out with something as complex as the universe. I began to realize the universe is indeed aesthetic. It might indeed just be a 3-dimensional fractal, but you have to reason about it. If you view quantum mechanics and mass relativity as the statement that nothing exists, you might think that a perfect number times a perfect number is a duplicate. X squared equals delta x, therefore very little exists, or a minimum of things exist. You look at things like energy wells and quantum mechanics, you're led to think the universe is probably minimal, like very much minimized in all its expressions. It's not nearly as complex as you might think. 36 hit on me immediately, and it's a little bit complex to think of that way, kind of just batch it together, piece it together. It makes sense in a lot of other ways, but thinking about it that tediously might seem a little bit haphazard, because a lot of people would like to say it's superstrings, it's 26-dimensional, or other things. And reason about it my way, you have to... Basically, what I recommend is taking about 10 years of college physics and getting frustrated with all the crap they teach you, so you just go your own way. Besides, you need that kind of preparation to really understand what I say anyway. But the theory is indeed consistent with all the advanced theories of physics, relativity, quantum mechanics. The 36 statements are... You might remember that 36 has factors of 1, 2, 3, 4, 6, 12, 18, and 36, and then backwards. So there's multiple ways of folding it, if you will, or forming rectangles out of it. Let's see, I believe that's 9. I'm not certain of that. I think it's 9 different symmetry forms. That plays a role too. 3 squared is 9. 2 to the third is 8. 3 squared minus 2 to the third is 1. It's one thing. That's a little bit elaborate again. Some people might think this is just numerology or advanced combinatorics. Indeed, does play a role. Quantum mechanics is basically about conjugation and pairs and interacting fields, and the Dirac-Spiner and relativity is about pairing up couplets into 4 2x2 matrices. So a lot of it's based in pairs, and also in threes, like the quarks and the gluons. 2 times 3 is 9. 2 plus 3 is 5, the strength of the electromagnetic field. 2 times 2 is 4, the strength of the gravitational field. That's how you integrate it, you flatten it out. And then what you use quantum mechanics is 3 rules, quantum field theory. There are 2 ways of expressing it. 2 times 3 is 6. Fluidic continuity is analytic functions for 6-dimensional fluids and planes is 6-dimensional. That is consistent. And you wonder what chaos is. The the way I introduce chaos, like indeterminacy of the three-body, not indeterminacy, but infinite complexity of the three-body problem, is that's a little bit hairy, because the problem with the determinate universe, or at least strongly determinate, is you get like waves too often and it just cancels to nothing, or forms a ring and cancels to nothing, or things like that. So the way for anything to exist basically is you have to have like symmetry breaking and 9 dimensions for chaos, and that means the three forces never cancel out for any two different points in space. There might be one point in space where the universe cancels out between the three forces. Is that rest? Or at least it transitions around the place. It might even form a spectrum, like a complete linear field, like a line full of different forces spread out across a Gaussian curve or something. The spread of the different forces. That might be three-dimensional, but whatever it is, it would be interesting to know stuff like that. For a long time, I viewed the universe as bifurcating, dividing in two, according to a time quanta. I don't really think it's that. It might be something like a quantized angular momentum, where each particle had general relativistic free momentum, but also was increasing or decreasing by a scalar integer multiplet. So it was falling off or getting bigger. The motivation for that was essentially that as the thing got smaller or bigger, you get quantum uncertainty or infinite terms, meaning it'd be a black hole or evaporation. Either thing is the same way, and there's insight in that. I think angular momentum is one of the better things to consider for that. You get a lot of neat things through it. It doesn't really work for linear momentum or displacement. You get something infinitely far away or moving infinitely fast, and with rotation and free particles, and it might be mismapped. You might get freedom under quantum mechanics and scalar quanta increases or decreases, integral scalar quantum decreases or increases angular momentum as a time clock for I think relativity. I just juxtaposed the two back and forth. One or the other. I forgot what I said first. But that's how I view chaos. It's just what it does. It forces the universe to reel, or it just has positive mass. It's a form of symmetry breaking. Even the Riemann signature is a form of symmetry breaking. There's motivation for the Riemann symmetry. Between 3 and 1 is 2, the particle couplets. So it forms like a 1, 2, 3 principle, where it's 0, 1, 2, 3, 0 energy, 0 force, 0 mass, 1 time dimension, 2 particles interacting, 3 space dimensions. The reason about them more tediously is a little bit hairy. It's basically why I view the Riemann signature as what it is. I also view it as 3 space coordinates, 2 Mobius strip rings, 1 flat ring, like a disc, or not a disc, but like a ring, like a band. The 2 Mobius strip rings duplicate to another band. The 2 bands duplicate to a Mobius strip in the space coordinates. Therefore, the Mobius strip doesn't exist. Therefore, the universe doesn't exist. The principles of rings are critical to my theory, like the idea that by making space a ring, you can achieve the effect that nothing really exists. It's kind of like why people like energy conservation, mass conservation, charge conservation. Essentially generates space as being a ring, therefore it doesn't really exist. And in the limit, you can just contract it to 0. You get something that doesn't exist. You can also say it doesn't. It has maybe infinite, but it also is ring-like. And there's ways of deriving a fractal from a ring. It's a little bit hairy, like saying that the universe might be kind of an eigenfunction spanned out across intervals, so it falls off. And even though it's a ring, it's really just a projection of a function onto its different eigenspectra functions. Fourier resolution according to index, or coefficient of the sine waves and cosine waves. It's basically what I have to say about my theory of physics. It's not really technical. Sometime later, I'll get into the idea of what the 36 equations mean. It's not really an equation. It's more like a statement, like a metaphysical statement, kind of like saying that nothing can exist, nothing is impossible, nothing is possible. Those are 2 of the 36 equations or statements. You may wonder why those statements are psychological, biological, logical, mathematical, physical, and there's a 6th one, I forgot what it is. But why those statements have so many interpretations, again, that's 36, not 36, but 6, has 6 different meanings for a while I wanted to break it up into a different, like saying that it was in one way mathematical, one way physical, one way logical. And I thought it might actually be saying like 2 things about math, 2 things about logic, 2 things about physics, 2 things about biology, 2 things about science, 2 things about philosophy. Yeah, philosophy was the 6th, and the 7th is theology. These are only 6 dimensions deep, or 6 elements deep. Like nothing is impossible, nothing is possible. 2 of the statements. That alone generates quantum mechanics. It's essentially the Heisenberg uncertainty principle. You think about it more deeply, a statement that nothing is impossible has 2 meanings. It means, or nothing is possible has 2 meanings. It means that nothing exists, and that nothing is possible means that nothing exists, and that something that is nothing can exist, meaning that the universe is both nothing and starts out as nothing that can exist. That may sound like identical statements. It's not really the same thing. It's like a boundary condition. You can basically say that you start with nothing. You can also say it's always nothing. You can also say that that's nothing is possible, meaning that it's both nothing and it's also possible. Those are different statements, but they're contained within one statement, so each has multiple meanings. That's why I was brought to through like things like the dialectic in Hinduism and Buddhism. Buddhism uses 2 symmetries, Hinduism uses 5s and 9s or something. So they also have different numbers, like Taoism uses 2s. I just realized it's probably 6s, and that's a little bit elaborate. Fusion of multiple of Taoism and Buddhism. They're not really that deep physicists, but you just think my way kind of led to that kind of way of thinking. The 3 symmetries in Buddhism are f of x equals minus f of x, minus f of x equals minus f of minus x, and minus f of x equals minus f of minus f of x. 3 ways you define symmetry in a functional analysis. This is one way of looking at it. I look at it that way kind of too. I came up with something called the Kármán equations. It's basically a term for the angular momentum quanta. It's essentially the only term in physics, the only equation in physics. It's 36 statements plus 1 Kármán equation plus the square of the number of Einstein field equations that are Einstein field equation. 10 times 10 is 100 times 36 plus 36 plus 1 is 137. It's the reciprocal of the fine structure constant, the only real constant in physics. That's the way I interpret that. You may think that's strange, why you would add and multiply in that order. Basically, you have to duplicate gravity because it's continuous, and you have to add the number of equations, and you add 1 for the Kármán equation. That's how you define it. Addition is a little strange in a theory like that. It's basically the Goldbach conjecture that calculation and proofs are impossible under addition of primes. You have to get into the Riemann zeta function pretty heavy to really see why that's inevitable in the universe. Why you need something that quantum mechanically unstable. Basically, my theory basically evolves with the fact that everything physics is imaginary, philosophy is negative, math is 0, biology is 1 or 5 or 2. Just call it something like probably 2 more likely. Logic is 2. Also, yeah, it's probably 2. Biology is 1 maybe. And psychology is 6 probably, or 3 or something. I don't think there are any duplicate numbers. There might be. It might be 1, 2, 3, 1, 2, 3. It might be that. I think it's 1, 2, 3, 4, 5, 6, but it might be 3 and 3. It's probably 1 and 2 and 3 twice. Those are the 6 disciplines. What I mean to say that the universe is made of 6 disciplines plus theology is that the 6 disciplines are like continuous, or they're like a class for dichotomy and categorization, meaning that the universe makes sense psychologically, it must generate life biologically, it must be logically consistent as a whole, or maybe in parts, one of the two. It must be mathematically true, and it must be physically real, or like those 6 things. And philosophically negative, or negative is a bit hard. It means that it tries to be as simple as possible. You may think that the idea of defining something as life as confluent with the laws of the universe is not really inconsistent. Life does exist in the universe, so it looks consistent. The whole thing is consistent. You might wonder how I got those 6 disciplines. I just fiddled around with the category for a while. Really, it's probably those 6. You think about it, math is probably essentially part of the universe. Like that it has to make has numeric consistency, at least generally, or at least in parts, 1 of 3 or 2 or 3 dimensions. What that means is that, math is strange because you can hypotheticalize about things that don't exist, or 11 dimensions or things that don't exist, and about statements like infinity and stuff that don't exist. That may seem strange to you, but it is indeed a reality. And I don't think the universe is entirely mathematical. Dirac was pretty far off when he said math should have physical beauty. He didn't really understand what he was saying. It's probably about the most incorrect thing he ever did. He really didn't have enough experience to make contrasts like that. He was very immature. He was trying. He was one of the better physicists we've had, but it's not in any remote way true. Physics and math are independent. They work together, but they're also independent. So you really have to kind of integrate them and use each one for what it's worth. And likewise, biology, psychology, logic, and other things like the other one, philosophy. You may say that math is logic. Math is not really logic. Logic is statements about truth and validity and existence and things, and plausibility even. It's not really the same thing as math. Math uses logic. It uses logically consistent, but logic is its own field. And I guess logic is more binary than a lot of ideas. Maybe there's something that's trinary logic, but it's usually binary. So it's a different idea than math. Math is usually more about reasoning about constructs, not really physical constructs, but that's why I say math is indeed a little bit physical. Physics is not really part math. Physics is about experimental observation and maybe consistency or the scientific method. It's not really about math. They use it, it's convenient, but it's not really about math. It's more philosophical, as you might have, like things about the statements about the universe not existing anywhere, only not existing as a whole, or not existing but only in parts, or everything in the universe canceling to zero. So the 6 fields are important to take into consideration. Each of the 36 statements must be about all 6, or maybe 3 of them twice, or maybe weaker, like 3 of them twice, and different selections of 3 of them twice. And it might actually force the number of statements much higher, like 216 or even higher. I really think it's just 36. It's more convenient to think of a duplicate, a square, i.e. a duplicate and a perfect number.
Get off that damn
you think
thing.
About it, it's a duplicate. Christina, please,
You're not making any
please
sense.
stop. It's a duplicate,
You don't make any
a perfect
sense.
number, and a maybe unity or something, or an integrated object.
You're an idiot. You're not
So
making any sense.
that's just the way it is. Let's see what else. That's my idiot roommate, Christina. She's always screaming. I guess that's all I have to say. There are other things that led me to conclusions like that. Like I said, in my theory, quantum mechanics mandates that everything has to be demonstrated in 2 ways. That's why there are 2 proofs of quantum field theory, S matrix and particulate. I think are the 2. Everything has to be provable in 2 ways, measurable in 3, flattened to an integrated whole, logical in 4 ways, electromagnetic in 5, and duplicate in 6. That's sort of the 6 disciplines. I'll get more into what the 6 numbers mean in a later lecture.